Hi everyone, today I am here to talk about the internship project which is made during the internship and it was presented by Srimati Aarti, Meenakshi K and Sita Lakshmi, and we are currently studying third year at National Engineering College. Myself Meenakshi, I am going to present the topic. What are the topics learned during the internship? Shall we move to the next slide? These topics learned during the internship. In first week they gave brief introduction about introduction to C, conditional statement, loops and operators, arrays and pointers, function and strings and storage classes, etc. In second week they gave introduction about embedded systems and microcontrollers. In our internship, microcontroller called PIC16F87788A was used, and also we got know about the various peripherals of PIC16F877A and various interfacing, and they give multiple quizzes every week and etc. Shall we see some introduction about these topics in upcoming slides? Introduction to C. We know C is widely used. It is a general purpose language, programming language that was developed in the early 1970 by Dennis Rich at Bell Lab. So where is C is used, we have to know. System software development, embedded software development, file system development, and OS kernel development, and many more. So the main features of the C languages include general purpose and portable. We also know that low level memory access, and it has fast speed and clean syntax. What typically C code contains? It have file header, preprocessor directive, the start of the program, command, statement and program terminations. So shall we move to the next slide? Conditional statements, loops and operators. What is conditional statements? These statements are used to control the flow of program based on certain conditions or expression. These statements allow you to make decision in your code by executing different blocks of code depending on whether it is specified condition is true or false. If it have if statement, if else statement, if else if statement, nested if and switch statements. Loop statements are used to repeatedly execute a block of code as long as certain condition is met. It have three types: for, while loop and do while loop. Nest operators. Operators means symbols that instruct the compiler to perform specific arithmetic and logical operation on operands. It have two things: operates on its operands and return a value. It have arithmetic operators. We also know about addition, subtraction, division, modulo and multiplication and so on. Relational operation like greater than, lesser than, greater than or equal to, lesser than or equal to and not equal to. Logical operators, logical not, logical and logical or. Increment and decrement operators we also know. Increment means increment the value plus 1 and decrement means decrement the operators by 1. So bitwise operators perform operation on bits. The operand type should be integral and it return value in integral form. And conditional operators. So shall we see the syntax of conditional statement and loops in next slide? Conditional statements. If else, it have if else, if and nested if. If statement, if the condition is true, inside the statement it will execute. If else, if contains two blocks, one for true expression and another for false expression. If condition is true, the if statement will execute, else the else block will execute it. If else if are used when the user has decided among multiple options. So we can use if else if. Nested if statement that is placed inside another if or if else statement called nested if statement. So switch expression, the switch statement is used when you have single expression that you want to compare against multiple possible values. Expression is equal to case 1, it will execute the case 1 statement, and it check for all the cases, and none of the cases are matched, the default statement it will execute it. Syntax for loop statement will discussed on upcoming slides. Loops, it have two types, entry control and exit control. In entry control it have two types, for loop and while loop. In exit control it have one do while loop. For is a keyword. In for it have initialization, condition and updation as within all single line. The loop will execute the code block as long as condition remains same, and after each iteration update expression is executed. While is a keyword, it loop repeats a block of code as long as specified condition is true. And do while is similar to while, but it execute the by the do while loop. The code block is first executed and then the condition is checked. If the condition is true, the loop condition to executed. So shall we move to the array and pointers topics? Array, we also know array is a collection of data with the same data type, and array have addresses or sequential. First element with the lowest address and last element with the highest address, we also know. Indexing start from 0 and should end with array size -1. For example, we say array of 5 will have to be indexed from 0 to 4. And pointers. Why pointers used in embedded C? To have C as a low level language being high level language, returning more than one value from function. Pointers in embedded C are variables that store memory addresses, allow you to directly access and manipulate memory locations, like configuring hardware register, managing data buffers and so on. So function. We know that function is a relation or expression involving one or more variables. It have three parameters like input, operation, output. It have syntax, return, data type, function name. Data type, we know that what the data is, whether the data is integer, float, double character and so on. So we have to mention the data type, return, data type, function name. Inside the parentheses we also give so many arguments, argument 1, argument 2 and so on, and it will execute the function body. So string, the next topic is string. The string is a sequence of characters or represented as an array of characters typically terminated by null characters, and it easily store ASCII and its extension. So we see the string libraries in the slides. String library function, and there is so many function, str length and strcpy. So first we see str length. It returns the length of the string name. strcpy of s1, s2, it copies the contents of string s2 and to string s1. str1 of str2 compares the first string with the second string. If string are the same, it returns the 0. strcat of s1, s2, it concord the s1 string with s2 and result the store in the first string. str lower of, it converts the string to lowercase. str upper of, it converts the string to uppercase. str of s1, s2, find the first occurrence of s2 in s1. So the upcoming topics are handled by Sita Lakshmi.
Okay, good evening everyone. Myself Sita Lakshmi from National Engineering College. Share my understanding about the embedded system. Here are the storage classes, different types of storage classes in the embedded system. They are auto storage class, register storage class, static local, static global and extend. The visibility of the storage classes are the auto register and the static local storage classes are within the block or within the function, but the static global and extend, but the static global's visibility is in the file and extend is in the program. Lifetime of these storage class is auto and register storage class are till the end of the block, like block function. Block and the static local and static global and the extend storage classes are till the end of the program, and their memory allocation was desired or was given by the was allocated for the auto storage class is located in the stack, and the register storage class is located in this register itself. Static local and static global and extend allocated in the data segments. Embedded system and microcontrollers. First of all, what is my embedded system is? Embedded system is in my opinion, it is a integrated system that is combined of hardware and software components, and it only performs a specific functions. And the three main components of the embedded system are hardware, software, and firmware. Some examples of embedded system are digital watches, traffic light controller, washing machines, toys, televisions, digital phones, a laser printer. And the important characteristics of embedded system are also mentioned in our slide. The embedded system performs only the specific task allocated by the user, and they are low in cost, and they consume low power, and but provide a high efficiency, and it is a minimal user interface, and it provides high stability and reliability, and it uses microprocessors and microcontrollers. And the block structure diagram of the embedded system was given. First of all, the microcontroller. Inside the microcontroller there will be microprocessor, RAM memory, and ROM memory, and they are connected with the internal bus structure. And from the internal bus, the data are given to the input and output ports, and from the output ports the data are also given to the internal bus structure. And from the physical devices, and there will be connecting and external circuits which has the input as physical devices, and they are also connected with the input and output ports and physical devices, and the input signal is given to the physical device and output. Now we are going to see about the microwave oven simulation. In this PPT we are going to share the contents like what is microwave oven and the software required for the simulation, and what is the difference between microprocessor and microcontroller, and the simulator that we are going to use, and demo project implementation, etc, etc. First, we are going to see about what is microwave oven. Microwave oven is commonly referred to microwave, which is used in our daily routine life. That is which is used in kitchen. Which is used to heat and cook the food by using the microwave radiation principle. It operates on the principle of electromagnetic waves. It operates on the principle of generating electromagnetic waves in the microwave frequency range. Its frequency is about high range. It's around 2.5 gigahertz. These microwaves are absorbed by the water, fats, and sugars in the food, and causing them to vibrate and generate heat through a process called dielectric heating. This heat makes the oven to cook or reheats the food quickly and in an efficient manner. Here we are going to implement the microwave in 4 modes: start mode, micro mode, grill mode, and convection mode. First one, start mode. In start mode, it is an action of initiating the oven to start the cooking process. And then is a micro mode. In micro mode, typically refers to, in micro mode, the microwave power levels and cooking times will reduce. This mode is often used when we want to heat or cook the food at the reduced power setting level. And next one is grill mode. The grill mode is a cooking function that combines with the microwave energy with a grill element, which is used to grill them, which is used for grilling and then sear and brown foods. It is equipped with heating coils that are responsible for grilling, toasting, and roasting, which is used to make the food very brownish and crispy. This The grill mode gives the food a crispy look and ensures that the interior is properly cooked or not. And then the third is convection mode. Convection mode is cooking function that also combines with the microwave energy with the fan and heating element. Why we are here using fan and heating element is, it is used to it is used for make the food even more brownish and crispy, and it is also used for cooking the foods like pizza and roasting meats and vegetables. And in the software required for the simulation is MPLAB IDE and Emerxte compiler and PIC simulator. Then the difference between microcontroller and the microprocessor is in microprocessor the memory and the input output component is connected externally. Therefore, the circuit is more complex. Microprocessor has less and the microprocessor has less number of resistors compared to the microcontroller. In microcontroller, the memory and input output pins are connected internally, so the circuit complex is very less, and it also has more number of registers than the upcoming slides will be explained by my colleague Srimati.
Hello everyone, myself Srimati. So now we are going to see about PIC Lab and its architecture. So PIC Lab means it is a simulator which is primarily designed for performing digital circuits, microcontroller and other electronic components. So it is especially designed for PIC controller. So PIC refers to peripheral interface controller. So in this PIC, um, many outer components like LEDs, buzzers, like LED buzzer and digital keypad, matrix keypad, CLCD. So CLCD refers to character liquid crystal display, which we will see in further slides. And ADC represents analog to digital. So temperature sensor, EEPROM and GPIO, general purpose input output. So these are the components connected in the controller. So next we are going to see about CLCD, character liquid crystal display. So it is display which shows letters, numbers and characters, and it is composed of 5 cross 7 or it may be 5 cross 11 dot matrix positions. So in each letter it will be made up of dots, and lines will be separated by and characters and lines will be separated by space in between them. So next we are going to see about ISR. ISR refers to interrupt service routine. So it is a software routine that in which a hardware invokes in response to an interrupt. So ISR examines an interrupt and it determines how to handle it, executes it, and it returns a logical interrupt value. So when the ISR is done, the paused process will be resumed. So next we are going to see about timer. A timer is a clock which counts down for a certain amount of period, like it may be a seconds or it may be a minutes or hours. So it is always done per second. It will alert us when the given process or the given time is exceeded or when it is completed. So next we will see about project demo.
So this is the project code, and we have written the code for microwave oven simulation. Now we are building it. So the build was successful and the hex file was also created. So now we are running this hex file. Now we are going to run the hex file in the PIC lab. So in this PIC lab, first we are going to load the hex file. After loading, powering on microwave oven. This is the starting. So here we are going to perform these 4 operations: micro, grill, convection and start. So first we will set the temperature. So here we are setting as 1000 watt as power, and now we are setting the timer. So let us set the time as 10 seconds. So for this 10 seconds the fan will run. After 10 seconds this fan will stop working. So the timer is running. So within this 10 second we can perform 3 operations. So after 10 seconds it will show us the time is up, and these 4 operations are we are going to perform. So now we are setting a timer. Okay, let us set the time for 1 minute and 13 seconds. Okay. Now asterisk is used to clear the value we have set, and hashtag is used to enter for the we are moving to next. So within this 1 minute, we can perform start, resume, pause, stop, these three operations with their respective numbers. So 5 is used to pause, and it is passed. And for resume, we have to click on 4. So 6 will stop the work. So we can also add the timing or reduce the timing in between when the clock is running. So now we are setting the time as now we are performing preheating, and we have set the timer as 175 seconds. So for this 175 seconds, the oven is preheating, and preheating will be occurred. So let us wait for that. So the time remaining is 50 seconds. After 40 seconds, this oven will be done preheating. Yes, and now the oven is done preheating. Uh, so we have now we are setting the timer for 30 seconds. So same within this 30 seconds, we can add the timer, like by increasing the timer value, we can increase the value of the timer. So first mode we are going to perform is micro mode, second mode is grill mode, third mode is convection mode, fourth mode is start mode. So when we select on one, the micro mode will occur, and we can set the timer for how many seconds the micro mode we have to perform. This is the demo. Thank you.